Hey guys, welcome once again. This is a continuation of lesson 2.3 from Unit 1. And in the first part, we talked about how a lot of mixture problems freak people out, but they come down to three groups a lot of times. So unit times quantity. So this is like a lot of times this is a price problem, a money problem. This you're going to literally see the percentage sign. We're going to see one of those in a second, and also distance equals rate times time. So we're going to jump right down here, and I want you to think about which one of those three problem number 3 is. Okay, so if you said the unit times a quantity, like this one, you are correct. So it's another problem similar to problem number 2. So I want you to set it up, just know it's going to be the same way. So I want you to kind of think about the way I set up problem number 2 and see if you can apply it to this problem. So go ahead and try that. Okay, so let's see how you did. Compare your answers with mine, but this is how you should have set it up. So they showed us in the problem that adult tickets were, or fees, I guess, were $15. Children's fees were $11, and then the whole group spent $589. So unlike this one, it tells us the total. So it's giving us this. So there's nothing to multiply. So I just want to be clear on that. But just like in this problem that I did with, oops, sorry about that. Okay, just like in this problem, I did the x and the 200 minus x. This problem is set up the same way. So we know that 47 people there were in their group. So I just called this x and this 47 minus x. It doesn't matter what you call x, so you could flip-flop those if you want. It's the same thing. Okay, so then just like this one up here, we're going to multiply, and then set it equal to this. So we have 15x plus 11 times 47, minus x equals 589. Okay, so go ahead and distribute, do the math, and see what you get. So here's my work. You should have gotten that x equals 18. If you did your math right, make sure you're distributing here. So go ahead, if you did not get that right, it's probably just like an easy fix. So go ahead and see what you missed. But now we have x equals 18. So I'm going to go up right now and I'm going to answer the question. How many adults and children are in the group? So I'm going to have two separate answers. I'm going to have an answer for the number of adults and the number of children. A lot of people don't take the time to just kind of slow down and really ask themselves the final question. But that is going to help you. That is like huge in these problems. So we set x equal to the adults. So I know that there were 18 adults, and the number of children, I'm going to take 47 minus 18. And so I get 29 children. So there are 18 adults and 29 children there. Okay, so this problem, remember how I said that you're going to see like a percent sign in the percent type problem. So we're going to do a problem like this. So let's go ahead and read through it. How many gallons of 5% milk? So we've got this must be added to 90 gallons of 1% milk to obtain 2% milk. So I want your mindset to be kind of in the same place as before. So we're still going to have these two things that we're adding together and then set it equal to the final box. So 3 boxes, but 2 we're adding together. So see if you can kind of make sense of it, and we'll go from there. So try not to get too mathy with this. So first of all, I just took the percents and turned them into decimals. And notice that they gave us like every single one. Oops, sorry, 1% and then 2%. So I mean that was given to you. So there wasn't a lot of thought process going into that. besides changing to decimals. Okay, now, how many gallons of 5% milk? So we don't know that. So that's why I called that X. I'm pretty specific about calling that X because the next one, they told us we have 90 gallons. And so that's where that 90 is coming from there. And so this is where I said, don't get too mathy. So I have this number of gallons plus this number of gallons equals this number of gallons. So that's where that X plus 90 is coming from. So a lot of times if you just kind of common sense your way through it and not worry about the math so much, in this, like in this part right here, you're actually going to help yourself, I think. Okay, so let's go ahead and do the math part. So the next thing that's going through my head is I'm going to multiply these together just like I've done before. So there's really not a whole lot of new stuff from this point on. So again, I'm just writing, I'm just turning this into an equation. That's it. Okay, now I'm going to show my work on this and we'll come back and talk about it. Okay, so even though the numbers were kind of yucky, the math wasn't too bad. So I ended up with x equals 30. So again, take the time to answer the question. So how many gallons must be added to obtain 2% milk? Well, remember, we found that x, so we're already there. So it's going to be 30 gallons. So guys, don't worry about this problem here. We're going to hit a problem like this when we're talking about systems. I think it's a little easier to explain there than here. There's not going to be a problem on your test like this, so we're not going to worry about it. So we are done with this lesson.